Hello everyone, welcome to today's tutorial on Pseudocode. If you are new to programming and are looking to understand the concepts in a clear, straightforward manner, you are in the right place. In this video, we will introduce the fundamentals of Pseudocode, breaking down complex programming ideas into simple to understand language. Here is what we will cover: the importance of using common words, keywords, and meaningful names when writing pseudocode to effectively communicate your algorithm ideas. We'll also talk about a comprehensive definition of the three basic control structures outlined in the structure theorem: the sequence, selection, and iteration. We'll also talk about the practical examples and illustrations to demonstrate how each of the three basic control structures is utilized in a pseudocode. We'll look at tips and tricks to help you master the art of writing pseudocode efficiently. By the end of this tutorial, you should have a solid understanding of pseudocode and how it serves as a powerful tool for designing algorithms and solving problems. But as I always say, don't forget to subscribe to our channel for more beginner-friendly program tutorials and hit the notification bell so you never miss an update. Let's dive into the world of pseudocode together and unlock the secrets of programming. At the beginning of this course, we looked at how to write a program. We looked at the 7 steps that you go through in writing a program. We saw how you should be able to define your problem. You should be able to outline your solution. You should be able to outline your algorithm. So, in outlining your algorithm, you could represent it in different formats. Some of them would represent their algorithm using flowchart. In today's video, we want to look at pseudocode, which is one of the popular representations of algorithms. Why do we use pseudocode? We are using pseudocode because it is easy to read and write. It allows programmers to concentrate on the logic, and it is very close to English language, which we are used to. And so this is why we want to go with pseudocode. In writing your algorithm, you need to issue out some instructions to be performed by your computer. But we can all agree that it is not everything that a computer can do. You cannot, for instance, tell a computer to lift a table. But there are some basic operations that every computer should be able to do. So when we want to communicate to the computer to perform such operations, how do we do this? Using the pseudocode, or the language we are about to learn, which is pseudocode. The first operation we'll look at is how do we tell the computer to receive information. Information can be received in two ways. Either the computer is reading from a file or accepting it from the keyboard. When you are reading from a file, you use the keyword read. But if you expect the input to come from the keyboard, then use the keyword get. So if you look at the examples that we have on your screen, we have read student name, meaning that the student name is probably on an Excel sheet or a Word document that is supposed to be read. And we have get system date, which means that the user is supposed to enter the system date, which will be received by your program. And so this is how to communicate to your computer to perform operations of receiving information from the user. But how do you tell your computer to give information out to the user? When you want to give information out to the user, you can either do this by just sending it to the printer. If you want to send it to the printer, then use the keyword print. But if you want to send it to a file, maybe an Excel sheet, a CSV, or a Word document, then you use the keyword write. You can use put, output, or display if you want to show it on the monitor for the user to see. But sometimes, even before you receive an information, you want to draw the user's attention to perform a certain action. So you put instructions out on the screen. The technical term for that is to prompt. And so you want to use the keyword prompt to receive or to draw the user's attention or send a message to the user to perform a certain action. So if you look on the screen, you would see that we have some examples like print program completed, write customer record to master file, put. All of these are ways of sending out information to the screen. What about if we want to perform some arithmetic operation? Users or a computer can easily perform arithmetic operation. If you want to do addition, subtraction, multiplication, division, or even use a bracket, then we need to use the keyword compute. If you use the keyword compute or calculate, then you are instructing the computer to perform one of these arithmetic operations. So just like we can see, if you want to perform the operation C is equal to F minus 32 times 5 over 9, you issue the keyword compute, and this is what tells your compiler or whoever is reading your pseudocode that you intend to perform some form of arithmetic operation. We also know that you can assign a value in computing. And so how do you do this in using pseudocode? When you want to assign a value to a variable in programming using or in your algorithms using pseudocode, you can either use the keyword initialize. So for instance, in the first example, we say that initialize total price to 0. What it means is that there is a variable called total price, and you want to put the value 0 into total price. And so when you state that initialize total price to 0, it means that put the value 0 into the variable total price. The same way, if you look at the second example, we have set student count to 0. What this simply means is that there is a variable called student count that you want to assign a value 0 to it. Or if you look at the third example, we have total price is equal to cost price plus sales tax. It means add cost price to sales tax, and the resultant answer should be assigned to the variable total price. Let us take note of something here. In programming, if you write cost price plus sales tax is equal to total price, that is wrong. What you should take note is that the variable always on the left hand side of the equal sign is the receiving variable. And so in this case, we are saying that perform the operations on the right and then put the result into the variable on the left. And so even though cost price plus sales tax is equal to total price is a perfectly correct equation in mathematics, in programming, we cannot say that put what is in total price into cost price plus sales tax. And so that's why we need to take note of this. This can also be represented using the back arrow. So when you see the same equation where the equal sign is replaced with the back arrow, it means the same thing. It means that assign the value to the variable on the back arrow. We can also use the keyword store and say that store customer num in last customer num. What it means is that there is a variable called customer number which is holding a value, and you want to put that value into another variable called last customer number. You understand? So you can use any of these examples here when you want to do an assignment, and all of these are perfectly acceptable. Then let us look at how you can compare and select alternate actions in your algorithms when you are using pseudocode. You use what we call the if then else statement. Let's assume that we want to find students who are part-timers, and so we give a condition. If student attendance is part-time, then if it is part-time, what do we want to do? We want to take one action, and in this example we are saying that add 1 to part-time count. Else, that means if the condition we gave above, what is the condition? The condition is compare what is student attendance status to part-time and see if they are the same. If they are not the same, what should you do? Then we give it an alternate action. Add 1 to full-time count. And so one of these actions will be performed based on the fact that the condition we gave above is correct or is not correct. And so what I want you to take note here is that don't worry if you do not understand how to use the if then else statement. What I want you to take from this lecture is that whenever you have alternate actions and you need to select in between them, you use what we call the if then else statement, or simply put, the if statement. This is what is used to select alternate actions when you are writing using pseudocode. Sometimes you have a group of actions that you want to repeat a number of times, or you want to repeat until a certain condition is met. In that case, you use what we call the do while condition. And so in pseudocode, to repeat an action, you use the do while statement to repeat an action. So these are about 6 operations that we have seen so far, and we have seen how you can write or you can issue instructions using pseudocode. We said you can receive information from the user using get or read. You can also give out information to the user using print, write, display, output, or prompt. And then we also said that you can perform arithmetic operation using calculate or compute. Then we came to when you want to select in between alternate actions, we said we use the if statement. And then if you want to repeat, you use the do while statement. So let's take note of all of this. They will become more conversant as we use them in writing of our algorithms. One thing we should also note is that now that we are going to use pseudocode to write our algorithm should always have meaningful names. They should always have meaningful names. So the algorithm would have to start with a name at the top and end with the keyword end. And then variables and objects should be represented appropriately. So for instance, if we are expecting 3 numbers from the user, those numbers would be received and put into variables on our computer. So we need to choose variable names for each of the data that we are going to receive. Also, note that in choosing your variable names, you cannot leave spaces in between them. And that's why sometimes you see that we use the underscore to close the spaces that are in between a 2-word variable. Now, let us look at something called the structure theorem. The structure theorem simply states that if we want to write an algorithm, almost all our algorithms would need 3 basic structures: sequence, selection, and repetition. It doesn't mean that all algorithms will need all 3, but you will need one or more of these 3 structures in writing your algorithms in pseudocode. What are sequences? Sequences are basic instructions that we have seen so far. So something like add 1 to page count is a sequence, or read customer record is a sequence. What are selection? Selection is being able to select in between alternate actions using your if statement. So if you look at the examples below, if condition P is true, statement is true case is what is going to be executed. Otherwise, statement is false case is going to be executed. And so this is how we select in between 2 different variables. So the next thing we are going to talk about under our structure theorem is how to repeat items. And we've said that repeating items simply means wrapping them around a loop statement. So when you have a do while statement, you provide a condition, and as long as that condition is true, all the instructions within the block would be repeated over and over and over again. And so for you to actually write out your algorithm for your program, the structure theorem simply states that you need one or more of these three structures: the sequence, the selection, or the repetition, in order for you to be able to write your program successfully. Let us look at an example that we saw before. And so if you look at this example, it says a program is required to read three numbers, add them, and print the total. We have seen from the earlier videos that once you are given a question like this, try and identify the inputs. So the inputs are what? Are three numbers. The output is the total. And then what have we been asked to do is to add them, to read, to add, and then to print. But we have also seen from writing our algorithms in pseudocode, as we've just discussed, that the input should be represented using variables. And so instead of just writing three numbers, we would represent them with number 1, number 2, and number 3, which are the names of the variables that we intend to hold the numbers that will be supplied by the user. And then when we add them, the new number that will be generated, we want to put it into a variable called what? Called total. And so at the end of the day, our algorithm will look something like this. So you see that our algorithm has a name, add three numbers, and then it has an end, the keyword end. And then the first one is we are reading, but we are not reading three numbers like we wrote earlier in the example where we're just using English to write our algorithm. We are reading number 1, number 2, and number 3. These are the variables that represent the numbers that we are going to receive. And we perform the arithmetic operation by introducing the operators, the addition operator. So number 1 plus number 2 plus number 3. And the answer that is going to be generated from here is being assigned to a variable called what? Called total. And that's why we are using the equal sign. And then at the end of the day, we are going to say print total. So this is how we intend to output our results. So this is simply writing our algorithm using pseudocode. Let us look at a second example. In the second example, it says that a program is required to prompt the terminal operator for maximum and minimum temperature readings on a particular day. Accept those readings as integers, calculate and display to the screen the average temperature calculated by maximum temperature plus minimum temperature divided by 2. Let us look at this. So from this question, we can see that we can identify that the inputs in this question will be what? Maximum temperature reading and minimum temperature reading. And then what will be our output? Our output will be what? Average temperature readings. What have we been asked to do? We've been asked to prompt, we've been asked to accept, we've been asked to calculate, and then we've been asked to display. And so let's go to our definition table and see how the definition table will look like. So the maximum and temperature readings are represented by these variables: max temp, min temp. So these are the names that we have chosen for the containers that we are going to use to store the two values that will be given to us by the operator. And so the output after the calculation is done, we are going to store it into a container that we are calling average temperature, shortened this way, right? What have we been asked to do? We've been asked to prompt for the temperature, get the temperature, calculate the temperature, and then display the output. Let us write this in this algorithm using pseudocode. Using pseudocode, we first have to write a name for our algorithm. So the name is our average temperature, and then we need to bring the keyword end to mark the end of our algorithm. And then now let us use our keywords. So we are asked to prompt. So we use the keyword prompt. And what are we prompting for? We are prompting for maximum temperature and then minimum temperature. Then after prompting, we are receiving what the user would supply. So get maximum temperature and then minimum temperature. Let us take note here. When you have more than two variables that you are getting from a user, you can separate them using what? A comma. And then now let's come to our arithmetic operation. We now say that because we received the maximum into this and the minimum into that, we will add max temp plus min temp all divided by 2. And the answer that we are going to get from here would be assigned to average temperature. And then now we can simply say output average temperature, which means that we want to display whatever the average temperature is to the screen. We will look at a third example, which is what? Calculation of the moving time, which we saw from the earlier example. Can we pause the video at this point and try our hands on it, see if we can do it on our own? At this point, I believe that you should have an algorithm that looks like this. And so if you're able to do it on your own, hooray, you've been able to successfully write your algorithm using pseudocode. So we would pause here and then continue in our next video. Thank you for watching. Again, press on the bell icon so that you do not miss any of our updates moving forward. Thank you very much for your time. I'll see you in our next video.